this is section 2.1. In this section, we're going to start by talking about average rate of change. So remember that average rate of change is just a fancy way of saying slope. Okay, average rate of change is just a fancy way of saying slope. So anytime you're asked for the average rate of change, you're just going to find the slope. So to find the slope of a line, we pick any 2 points. I see a point right here. I see a point right here. Any two, we call those lattice points because if you think of your grid as a lattice, they're the points that fall at intersections, or they're the points that have integers as x and y. So we call those lattice points. So we're going to look for any 2 lattice points. To find the slope, we measure the rise and the run. So this rises by 1, 2, 3, 4, 5, and runs by 1, 2, 3, 4, which makes the slope 5/4. It went up 5 and over 4. So my slope is 5/4. Okay? So then if you're asked to find the slope given 2 points, remember that the equation for slope is y2 minus y1 over x2 minus x1. And so we could label these x1, y1, x2, y2. So then that would be -7 minus -1 over -6 minus 2. And then -7 minus -1 becomes -7 plus 1. So that's a -6. -6 minus 2 is a -8. And then we can reduce that. 6/8 reduces by 2. And because they were both negative, negative divided by a negative is positive. So my average rate of change from here to here, 2/3. Okay? Slope, 7th grade math. Okay, so to determine something that is linear, a linear function has a constant slope. So hang on, let me just close my door. So in order to determine whether or not something has a constant slope, we're going to compare our ratios of change. Do you want to go? We're going to compare our ratios of change and make sure that it's constant. So to compare the ratios, you're going to find your differences in your y's and your differences in your x's and check your ratios. So -1 minus 9 is -10. -11 minus a -1 is -10. -21 minus a -11 is -10. So my rise is always -10. 5 minus 0 is 5. 10 minus 5. 15 minus 10. And then what we actually want to compare here is the ratios. So -10/5, -10/5, -10/5. So you see how we got the same ratio? All of these would reduce to -2. That means this is linear. If even one of these was different, it would not be linear. Let's keep going because I bet at least one of these is not going to be linear. 10 minus -5 is 15. 25 minus 10. 40 minus 25. 5 minus 0. 10 minus 5. Oh, look at that. Three, 3, 3. So yes, that one's linear as well. Okay. 13 minus 16 is 15. 61 minus 31 is 30. 76 minus 61 is 15. 5 minus 10, 5. So let's check our ratios. 15/5, 30/10, 15/5. 3, 3, 3. So notice here that one of my ratios was different. It was not the exact same, but it did reduce to the exact same value, which means this is linear. Okay. 34 minus 9 is 25. 109 minus 34 is not math I feel like doing in my head, especially at this hour. 75. 234 minus 109. I knew that one. 5, 5, 5. So then we have 25 over 5, 75 over 5, 125 over 5. Oh, that's not 25. That's 15. See how here my ratios reduced to different values? That means this one is not linear. Okay, so as long as your ratios all reduce to the same value, that means that your rate of change is constant, which means that your function is linear. Okay. Okay. Given the graph, write slope intercept. Okay. We all know slope intercept. Our good friend y equals mx plus b, where m is the slope and b is the y-intercept. So let's use this graph to find both. So let's find 2 points. I see one right here and then one right here. Any 2 points. So this went 1, 2, 3, 4, 5 down and 2 over. So that means my slope is a negative 5 over 2 because it went down 5 and over 2. Also, this is a negative slope because it's decreasing. Anytime you have a decreasing line, your slope should be negative. Okay. And then your y-intercept, it crosses the y-axis there at 1. So that means that your y-intercept is 1. So then the equation of this line is y equals negative 5 halves x plus 1. And then last but not least for this section, we're going to, again, use our y equals mx plus b. The first thing that we're going to do is find the slope. So they tell me that it's linear. So I'm going to assume that every ratio is going to be the same because it's linear. So I can pick any 2 points here and find the ratio. So what is negative 126 minus negative 36? So this has a difference of 90, negative 90, and this has a difference of 20. So then my slope would be negative 90 over 20, which would reduce to negative 9 over 2, or negative 4.5. What else? Okay, or if you don't like doing it that way, then you could do y2 minus y1 over x2 minus x1, but really that is literally exactly what I did. I did y2 minus y1 and got negative 90. I did x2 minus x1 and got 20, and I divided them. So I did y2 minus y1 over x2 minus x1, just a little differently. Okay, so now that I have my slope, I take my slope and any point. So let's say that m is negative 9 halves, x is 10, and y is negative 36. I plug these 3 in to y equals mx plus b, because then the only thing that I'm missing is b. So this is how I'm going to solve for b. I'm going to say negative 36 equals negative 9 halves times 10 plus b. Y mx b. Okay. Negative 9 times 10 is a negative 90, divided by 2 would be a negative 45. And then add the 45 to both sides. So b is 9. So that makes the equation of my line negative 9 halves x plus 9. Oh, I lied. There's one more page of these notes. Did I say last but not least? Or was there not? I thought both of these were 3 pages. No? Okay. So then here, if you're given an equation and you're asked to find the average rate of change and the intercept, well, the average rate of change is the number in front of the variable, so that's 47. And the intercept is this number over here, so that's 0.82. They might just want 82, but usually if they ask you for an intercept, they want a point. So again, here we go. Now, if they ask you for units, which is what they want here, the slope is always y per x. Keeping in mind that this is y and this is x. So if this says C of n is a monthly charge, that's my y. So that's a monthly charge per n is in dollars. Nope. Per n is the number of minutes talked. Monthly charge per minute. So, well, wait a minute. Monthly charge, that's just a dollar amount. So this is dollars per minute or cost per minute. And my slope is 0.05. So that's going to be $0.05 per minute. And then my initial value is always a y. So if my y value is the monthly charge, then that means that you're $21 initially. So what this is saying is that your phone bill will be $21 plus 5 cents per minute. Hope that makes sense. A town's population has been given linearly. In 2003, the population was 37,000. The population has grown by 1,200 people each year. So 1,200 per year means that is my slope. Write an equation for the population, the number of years after. So if they want the number of years after 2003, then 2003 is my initial value. So since they say after 2003, then that means 2003 is where I'm starting from. That makes my y-intercept 37,000. And my slope 1,200. I was just checking to make sure that it didn't say like in thousands. It doesn't. So then my equation would be P of x equals 1,200x plus 37,000. Okay. The population will reach 33,100. 83,100? Man, that's little. 88,100? I really can't read what it says there. Let's say 88,100. The population will be 88,100 in what year? So then if that's a population, P is population. So I'm going to plug that in over here. So let's subtract the 37,000. $51,100 divided by 1,200. So then x equals 42.58. But that's years since 2003. So if 2003 was my initial, then that means this is the year 2045. And it's about halfway through that year, but they're asking during the year. So this is the year 2045. This 0.58 just tells me that it'll be in like July of 2045. Okay, the population in 2009. Well, 2009 is 6 years since 2003. So we're going to plug in 6 for X. $1,200 times 6 plus 37,000. Okay. So the only key here is to make sure that you know whether they're giving you an X or a Y. Okay, this one said P of X was the population, so I knew that was the Y. This one said X was the number of years since 2003, so if they give me a year, I knew that was X. Okay. And now this is the last one. A clothing business finds that there's a linear relationship between the number of shirts N it can sell and the price P it can charge per shirt. In particular, historical data shows 6,000 shirts can be sold for $40 each, while 8,000 shirts can be sold for $28. Well, they just gave me 2 points. So I guess if they give me 2 points, I'm going to make a line. So 28 minus 40 over 8,000 minus 6,000. That's going to be a negative 12 over 2,000. You get negative 3 over 500. Negative 0.006. So that's my slope. Here's my x1, y1. So that is 40 equals negative 0.006 times 6,000 plus b. And then add the 36. So b is 70. So then my line would be, not y, p. Make sure that you use their letters, because if you use y and x, you're going to get it wrong. Negative 0.006 n plus 70. Okay, that's our review on linear equations. And I say review because TBH, you hopefully remember these from whenever you learn them.